What happens to quantum superposition after measurement? Imagine a tiny particle that can be in many places at once, like a super busy traveler with multiple tickets. Before you look, it's in a superposition, meaning it exists in all possible states simultaneously. This is what makes quantum mechanics so fascinating. But what happens when you finally check on it? Does it stay in all those places, or does it pick just one? Let's find out. When you measure a quantum system, like a qubit, its superposition suddenly collapses into a single, definite state. Think of it like flipping a coin that was spinning in the air. Once you catch it, it shows either heads or tails. Before the measurement, the qubit was in a mix of both states with certain probabilities. After you measure, it's locked into one of those states, and the superposition disappears. This process is called the collapse of the wave function. The wave function is a mathematical description that shows all the possible states a quantum system can be in. When you measure, this wave function shrinks from many possibilities into just one. The chance of ending up in a particular state depends on the coefficients in the superposition, which are squared to give the probability. So, if the superposition has a higher coefficient for one state, you're more likely to see that state after measurement. The reason this collapse happens is still a topic of debate among scientists. Some say it's an instant event caused by the act of measurement itself. Others believe that the wave function never really collapses but instead splits into many branches, each representing a different outcome. This idea is called the many worlds interpretation, where all possibilities happen in separate, parallel universes. Decoherence also plays a role here. It's like the system gets tangled up with its environment, causing the superposition to fade away. This makes the system look classical, like it has only one state. But decoherence alone doesn't pick which state the system ends up in. It just explains why superpositions are not seen in everyday life. In real-world quantum technologies, measurement is a key step. For example, in quantum computers, measuring a qubit ends the quantum process and gives you a definite answer. This means you lose the superposition's power to do many calculations at once. So, measurement is both a bridge and a barrier between the strange quantum world and the familiar classical world we live in. In the end, after you measure a quantum system, the superposition is gone. It's replaced by one specific state, chosen based on probabilities. This step is what connects quantum phenomena to the world we see every day. Understanding this process helps us develop new technologies like quantum computers, secure communication, and ultra-sensitive sensors.